Hey guys, it's Superior and welcome to C++ tutorial number 31. In this tutorial we're going to be looking at recursion, function recursion, obviously. So to demonstrate this, I'm going to be using I'm going to be making a recurring factor function, which, in maths, when you have like 5 exclamation mark, it means 5 times 4 times 3 times 2 times 1. Oops. So that's basically what I'm going to be using as an example. Before we get on to that, what is recursion ultimately? It's pretty simple. If a function is a recurring function, what actually happens is it's either that function calls itself, okay, or the function is called, that function then calls another function, and the other function calls the original function, which would be recursion. So basically, any situation where your functions are being constantly called, okay? Before we get started, let's take a look at how we'd make the factor function just as a normal function, no recursion involved. So we're just going to make the header, it will return an integer, it's called factor, and it takes one integer, which is the number to factor. Then we're just going to say assign the result to the assign the factor variable, the value inside the factor variable, to the variable result. Then for we're going to start a for loop, making a new integer called I and assigning a value of factor -1. The reason we have the -1 is because we already have one bit of the factorizing done. For instance, before this statement, what we actually have to still do is this. Okay, but after this statement, what it does is we've already got the times 1 part, because we've assigned just the value by itself, so we can take that away, and then we just need to do it 4 times in this case, so we're doing -1. Okay, that's just the reason why. Then we're saying while I is greater than 1, I minus minus. That's just simply because it's easier to do it this way than it is. Actually, it doesn't really matter. You could say int I is equal to 0, while I is less than factor -1 I++. I just thought this seemed like an easier to understand way. I don't know. Or maybe I just wanted to change, rather than using ++, I use -. But anyway, and then inside the for loop, we're just doing result times equals I. So we'll end up with, so to start off, we have, for instance, let's say 5. Then 5 times 4, 20, 20 times 3, 60, 60 times 2, 120. So that's the result of 5 factorial, okay? And then we just return the result, okay? Now, this is pretty hefty, okay? And it can actually be done a lot more simply with recursion. And the way we do that is like so. So it's exactly the same function declaration, except it's called recur factor, just for short. What we're going to do, ignore this for just the moment. What we're going to do is, the only thing that really is important in this case is the return statement, and what we're actually doing is saying return factor times recur factor, and then we're making another function call, and we're calling it with factor -1. Okay. Now you might be confused as to, apart from this multiplication, how are we actually going to end up with a multiplication? Well, that's what we have this for. So we say if factor is equal to 0, or actually it probably should have been 1. Factor is equal to 1. That would work as well. If factor is equal to 1 or 0, doesn't actually matter that much. Then return 1. So what's going to happen is, if we called this with 5, for instance, I'll just do a little diagram down here, diagram sort of thing. Okay, so to start out with, we're just going to have 5. I'm just going to use commas to separate it because that's easiest. Then it's going to call, the return statement is going to say return 5 times recur, I'm just going to say recur for short, 4. Then this function is going to say, actually it doesn't know this yet, so I'm just going to put factor minus 1, or 5 minus 1, that's the easiest way. Then what's going to happen is inside this function call, it's going to say return 5 minus 1, which is, as we know, but it doesn't actually know, 4, and then 5 minus 1, we'll just say. Then that function's going to call 5 minus 1 times recur 5 minus 1. Then that function is going to call 5 minus 1 times recur 5 minus 1, and now 5 minus 4 is equal to 1. So what's going to actually happen is in this function call, it's going to say, it's going to go into it, and it's going to hit this if statement, and in this case 5 minus 1 is equal to 1 because that's 5 minus 4. So it's going to say if factor equals 1, that's true, then return 1. So what's actually going to happen is it's going to replace this with a 1, okay, and it's so just to make it easier to read, we're going to write in the actual numbers now. So it's going to return 2 minus 1, that's equal to 2. Okay, 5 minus 1 minus 2 is 3. Then that's going to return 3 minus 2, 6 into this one. Then 5 minus 1, sorry, mind blank, 4. 6 fours are 24. And 24 is going to return into here. 24 times 5 is, I don't actually know, let's just do it on the calculator. I mean, I'm assuming it's 120. 24 times 5, 120, there we go. And so, when we did it this way, it was right. It came out as 120, and this was the easiest way to understand it, is to do it this way. But when we cut it down with recursion, it's a lot shorter, and as we can see, we get the same results. Okay, so hopefully that everyone understands recursion now. That's pretty much the whole tutorial. All I'm going to do now is demonstrate these two functions working. So let's give it a shot. Okay, there we go. They return the same answer, which is 10 factorial. Let's test 10 factorial in the calculator. 10 factorial, 3628800. 3628800. Okay, so it looks like both those functions are working. So, generally, you won't use recursion unless it's for something small, like a calculation function like this, okay? You might use it for something big, but in my experience, I wouldn't use recursion for something that's too big, because, you know, recursion is, I'll admit, confusing. So when you use it in something that's pretty big, you know, it's more than just a small calculation function, it might get a bit confusing. But, you know, feel free to use it and, you know, experiment with it, because, of course, that's the easiest way to learn how to use it. And I'm sure a lot of you will be a bit confused about it to start with. So, like I said, just play around with it, see what you get. And yeah, over and out.